All right, so get this. Today's deep dive is into something called nuts one. And it's not your average programming language. I'm looking at the nuts one programming 6x9.pdf that you sent over. And it's being called a money programming language, which I got to say has my mind racing with possibilities. Imagine coding your way to financial success.
It's certainly an intriguing concept, yeah. What I've gathered so far is that Nuts One seems to really prioritize accessibility, making programming more approachable for those who might feel intimidated by more complex languages. But don't let that simplicity fool you. There's a lot to unpack here.
Okay, I'm all ears. So what's the first thing that jumps out at you about nuts one? What makes it tick?
Well, one of the most striking features is its structure. Nuts One programs are built using a series of what they call nets files, which are essentially text files containing the program's instructions. But here's the catch. Each file is limited to just 5 lines.
Wait, 5 lines? That's surprisingly restrictive. I mean, I get keeping things concise, but 5 lines seems extreme.
It might seem counterintuitive, but this limitation is actually one of Nuts One's strengths. It forces programmers to break down their programs into smaller, more manageable modules, you see. So instead of writing one massive, monolithic file, you create a chain of interconnected 5-line files. And this is where the concept of flow control comes into play, which, by the way, is a fundamental programming concept across, well, almost all languages.
Flow control, huh? That sounds familiar, but right me.
Sure. Think of it like directing traffic in your program. Flow control dictates the order in which instructions are executed. And in Nuts One, this is managed through a special variable called dtemp, which stands for destination. At the end of each 5-line file, you set the DST value to point to the next file you want the program to execute.
So it's like creating a choose-your-own-adventure story for your program. Each file presents a set of instructions, and the DST value determines which path the program takes next.
That's a great analogy. And this chain of files, all linked together by the DST value, this forms what's called a nuts-oriented software.
Got it. So we've established that nuts one programs are built from these interconnected 5-line files. But what kinds of instructions can we actually give within these files? What's the language like?
Well, Nuts One has a surprisingly straightforward set of commands, even for beginners. One of the most basic yet essential is the emp command, short for emit, and as you might guess, it's used to display text on the screen.
So embits is our way of making the computer talk to us, like giving it a megaphone.
Precisely. And to use it, you simply assign the text you want to display to the emp variable using the set command. For example, if you wanted to display the classic hello world message, you would write set empty hello world. Then, in a subsequent file, you would simply use the empty command on its own line to actually display that text.
Hold on a second. So we're not just directly telling the computer to print hello world. We have to store the message in this emits variable first.
Exactly. And this highlights a key concept in programming the use of variables. They act like containers for storing information that our program can then use. You'll find variables everywhere, not just in Nuts One. So in this case, we're assigning the text hello world to the emp variable. And then when we use the emp command later, it's like saying, hey, computer, remember that text I stored in the emp variable? Show it to me now.
Ah, I see. So the empty command is less about the specific message and more about where to find it. It's like a treasure map leading to our text.
I like that. So for our Hello World program, we'd have one file that sets the DS2 to point to the next file and sets the emp variable to our message. Then the next file would actually use the empty command to display it on the screen. But there's one more piece to the puzzle.
Ooh, don't leave me hanging.
Well, remember how we talked about flow control? We need a way to tell the program to pause so we can actually see our hello world message before the program ends. And that's where the break command comes in.
Okay, I'm guessing BRIC is short for break.
Right on. The break command acts like a pause button, halting the program until the user presses a key. It gives us a chance to admire our coding masterpiece.
Makes sense. So our third and final nuts file would just contain the BRIC command to keep the text on the screen.
Almost. Remember the DST variable. Even at the end of our program, we still need to tell Nuts One what to do next. In this case, we would set ds to exit, which signals that the program is finished.
All right, let me see if I've got this straight. To create a simple hello world program in Nuts One, we need 3 5-line files. The first one sets the DST and stores the message in the mds variable. The second file actually displays the message using the mts command. And the third file pauses the program at the BRIC and sets ds to exit to signal the end.
You nailed it. It might seem like a lot of steps for something so simple, but this modular structure is what makes Nuts One so unique. It encourages you to think about your program as a series of interconnected modules, each with a specific purpose.
And this modularity probably becomes even more important as we start building more complex programs, right?
Absolutely. Imagine you want to display multiple messages, like a welcome message followed by instructions. You could do that by simply chaining together more inits commands and managing the flow with the ds variable.
So you just keep adding more nuts files, each with its own dst value and enst command, like building blocks of a larger program.
Exactly. It's like assembling a puzzle, but instead of a picture, we're creating a functioning program.
But what if we wanted to add a little flair to our multi-message program? Say, we want to clear the screen before displaying each new message. Is there a way to do that in Nuts One?
There is. Nuts One provides the seats command, short for clean the screen. You would simply insert a nuts file containing the six command before displaying the next message. So the flow would be set the first message, display it, pause with Burke, clear the screen with seats, set the next message, display it, and so on.
Got it. So we can control not only what messages are displayed, but also how they're presented on the screen. It's like we're directing a play, setting the stage for each act.
That's a great way to put it. But you know, even the most captivating play needs audience interaction to truly come alive. And that brings us to another important aspect of Nuts One user input.
Ooh, user input. Now we're talking. How does Nuts One handle that? What's the magic word?
The magic word is chke, which stands for create a text area. It allows the user to type in text during the program's execution, essentially making our programs interactive.
So it's like adding a prompt that pops up and says, hey, user, tell me something.
You got it. And whatever the user types in is stored in a special variable called, you guessed it, chke.
So we could create a program that asks for the user's name and then uses that input to display a personalized greeting, like welcome user's name.
Exactly. First, you would use the chke command to display a prompt like, please enter your name. Then you'd use the chke command to let the user type their name. Finally, you'd set the mn variable to something like welcome %to% and use the mn-pacta command to display it.
Wait, what's with the mn-peta%? Is that some kind of secret code?
Not quite a secret code, but it is a special way of accessing the value stored in the chke variable. Whenever you want to use a variable's value in Nuts One, you enclose its name within percent signs.
So if the user typed in Alice, the program would display welcome Alice. Because %to% gets replaced with whatever they entered. That's pretty neat.
It is. This ability to take input from the user and use it in our program opens up a whole new world of possibilities. It's like we're having a conversation with our program rather than just giving it a set of pre-programmed instructions.
Wow, this is already blowing my mind. We've gone from displaying a simple message to creating interactive programs that respond to user input, all within this unique 5-line file structure. And I have a feeling we've only scratched the surface of what Nuts One can do.
There's so much more to explore. From commands for comparing values and performing calculations to even creating delays in program execution.
Hold on, delays. What would you even need that for?
Imagine you're building a countdown timer, or a program that needs to wait a specific amount of time before doing something. That's where the diddly command comes in.
So, deadly, as in delay. Does it literally make the program just sit there for a specified amount of time?
Pretty much. The diddly command takes a value, which represents the number of seconds to pause the program. So if you set diddly to 5, the program will wait for 5 seconds before moving on to the next instruction.
Okay, I can see how that could be useful, especially for creating programs that need to be time sensitive or have a specific rhythm to them.
Exactly. The diddly command, along with the other commands we've discussed, gives us a surprising amount of control over the timing and flow of our programs.
This is incredible. It's like we're conducting an orchestra, controlling not only the notes, but also the tempo and pauses between them. We're going to need a whole other deep dive just to cover all these other commands and their potential.
We might just need that. But before we get too carried away, there's one more fundamental concept in Nuts One I think we should touch upon. Procedures.
Procedures. All right, lay it on me. What are they all about?
Think of procedures as mini programs within our larger program. They're essentially blocks of code that we can define once and then reuse multiple times throughout our program.
Oh, so it's like creating a reusable recipe for a specific task. Instead of writing out all the steps every time we need to perform that task, we just refer to the recipe.
That's exactly. It's all about efficiency and avoiding repetition.
So it's like we're creating our own custom commands in Nuts One, tailoring the language to our specific needs.
You're catching on quickly. And this idea of defining procedures has far-reaching implications. You see, procedures can also be used to create what the source material calls system software.
System software. That sounds important. What does it mean in the context of NUTS 1?
System software are essentially procedures that are designed to be used by other programs rather than directly by the user.
So it's like building a tool that other NUTS 1 programmers can use in their own programs, extending the functionality of the language itself.
You've got it. And this ability to create and share system software hints at the immense potential of NUTS 1 as a collaborative platform for building sophisticated applications. But I think we should pause here and save the exploration of system software for the next part of our deep dive.
Agreed. We've covered a lot of ground already, from the basic syntax of NUTS files to the power of procedures. We've even started to see how NUTS 1 could be used to build real-world applications.
We have. And I think it's safe to say that NUTS 1 is a language worth paying attention to. It's simple yet powerful, and its potential is only just beginning to be explored.
Well, consider my curiosity officially piqued. I can't wait to dive back in and see what other surprises NUTS 1 has in store for us. Join us for part 2 of our deep dive, where we'll delve deeper into the world of system software and explore even more fascinating aspects of this unique programming language. Welcome back to the deep dive. I'm still reeling from all the NUTS 1 knowledge we unpacked in the last part. Who knew a programming language could be so, well, intriguing?
It's certainly captivating. The more we delve into NUTS 1, the more I appreciate its blend of simplicity and potential.
Absolutely. Last time we left off talking about system software, which sounded pretty intriguing. I'm ready to dive deeper into that. But first, I'm curious about some of the other commands NUTS 1 has to offer. The source material mentioned something about comparing values, which feels like it could be a game changer in terms of what we can build.
You're right, that's a crucial piece of the puzzle. The chke command, short for check if equal, allows us to compare two numerical values and make decisions based on the outcome.
Okay, so it's like asking the program, are these two numbers the same? But what happens next? What did the program do with that information?
That's where the action value comes in. Along with the two numbers we want to compare, the chke command also takes an action value, which is essentially a pointer to another NUTS file.
So it's like a fork in the road for our program. If the numbers match, it goes down one path. If not, it takes a different route.
Precisely. This is called conditional execution. We're essentially telling the program, if this condition is true, then do this. Otherwise, do something else. It's a fundamental concept in programming, and it allows us to create programs that can respond dynamically to different situations.
I see. So trait gives us the power to compare numbers and make decisions based on whether they are equal. What about doing actual calculations with those numbers? Can NUTS 1 handle that too?
It certainly can. NUTS 1 has dedicated commands for addition and subtraction, add and subtract, which allow us to perform basic arithmetic operations.
All right, so we can add and subtract. Seems straightforward enough, but I'm guessing there's a bit more to it than just typing add or subtract into a NUTS file.
You're right to think so. Let's take the add command as an example. First, we'd set the DSD value, as always, to, direct the flow of our program. Then we need to define the two numbers we want to add, which we do using variables.
Right, variables. Those handy containers for storing information. We could either set those variables directly, like saying set num1 5 and set num2 3, or we could get the numbers from the user using the text the command we talked about earlier.
That's exactly right. Once we have our two numbers stored in variables, we simply use the add command on its own line, and NUTS 1 does the math for us.
So the program knows which numbers to add based on the variables we've specified. Makes sense. But where does the result of the calculation go?
That's an important detail. Whenever we perform a calculation in NUTS 1, the result is automatically stored in a special variable called awk, which I like to think of as standing for outcome.
Outcome, that makes perfect sense. So to display the result of our addition, we would set the emit variable to something like the sum is 0.5% set a percent, and then use the emted command to show it to the user.
Spot on. It's a two-step process. Perform the calculation, and then access the result through the awk variable.
Okay, I think I'm starting to get the hang of this. We can compare numbers, make decisions based on those comparisons, and perform calculations. It's like NUTS 1 is becoming a little calculator right before our eyes.
It is. And speaking of calculators, let's imagine we want to build a simple addition calculator using NUTS 1.
Ooh, I like where this is going. Walk me through it.
First, we'd need to get two numbers from the user. We'd use the msmt command to display a prompt like enter the first number, followed by the chke command to let the user type in their input. We'd store that input in a variable, maybe num1.
Okay, then we'd do the same thing to get the second number, maybe storing that one in num2. Then we'd use the add command to add num1 and num2. And the result would be automatically stored in the aux variable, right?
You're following along perfectly. Finally, we'd use them to display a message like, the sum is 6% to show the user the result.
That's pretty cool. We've built a basic calculator in just a few lines of code. But there's one thing that's bugging me. Wouldn't that just calculate the sum once and then end the program? What if we wanted to create a calculator that could be used repeatedly without having to restart it every time?
That's a great observation. You're thinking like a true programmer. And you're right, we need a way to create a loop in our program so that it can keep running and performing calculations until the user decides to stop.
Loops. I've heard of those. But how do we create one in nuts1?
It's actually quite simple, and it involves using the DST value and the Burk command in a clever way.
Okay, remind me how those work again.
The DST value, as we've discussed, tells the program which nuts file to execute next, and the Burk command pauses the program, waiting for the user to press a key before continuing.
Right, so how do we use these to create a loop in our calculator?
Instead of setting the DST value in the final nuts file to exit, which would end the program, we can set it to the name of the very first nuts file in our calculator program.
Ah, I see. So after displaying the sum, the program would jump back to the beginning, prompting the user for new numbers and essentially starting the calculation process all over again.
Exactly. It's like creating a circle of instructions. And to make it a bit more user-friendly, we could insert a Burk command before that final DST instruction, giving the user a chance to see the result and press a key when they're ready to do another calculation.
So with a simple tweak to the DST value, we can turn our one-time calculator into a continuous loop. That's pretty ingenious. It's amazing how much we can accomplish with just a few simple commands.
It is. nuts1's beauty lies in its elegance. It allows us to build surprisingly sophisticated programs with a limited but well-chosen set of tools.
This is truly remarkable. We've gone from displaying a basic hello world message to building a fully functional calculator, all within this unique 5-line file structure. I'm beginning to see why nuts1 is being called a money programming language.
Yeah.
With the ability to create such a wide range of applications, the potential for building and selling nuts1 software is definitely there.
Absolutely. And as we continue to explore nuts1, we'll discover even more features that contribute to its power and potential. But for now, I think it's time to shift our focus back to the concept of system software that we touched on earlier.
Okay, I'm ready to delve deeper into that. It sounded like we were getting close to unlocking a whole new level of programming possibilities with nuts1.
You're not wrong about that. Remember how we talked about procedures being like reusable recipes for specific tasks? Well, system software takes that concept to the next level.
I'm all ears. Tell me more.
System software are essentially procedures that are designed to be used by other programs rather than directly by the user.
So it's like creating building blocks that other programmers can use to construct even more complex and sophisticated applications.
You've got it. Think of it like this. Imagine you're building a house. Instead of having to create every single brick and piece of lumber from scratch, you can use pre-made components like walls, doors, and windows.
That's a great analogy. So system software provides these pre-made components for building nuts1 programs. It allows programmers to leverage the work of others and create more complex applications without having to reinvent the wheel every time.
Precisely. And the beauty of system software in nuts1 is that it's built using the same procedures that we've already discussed. So anyone familiar with nuts1 programming can, in theory, contribute to the ecosystem of system software, making the language even more powerful and versatile.
This is starting to feel like a whole new world is opening up before us. We're no longer just writing simple programs, we're creating tools and components that others can use to build their own creations. It's like we're moving from being builders to becoming architects of the nuts1 world.
That's a fantastic way to put it. And the shift from individual programming to collaborative development is one of the things that makes nuts1 so exciting. It has the potential to foster a vibrant and innovative community of programmers all working together to push the boundaries of what's possible.
Wow, I'm completely captivated by this idea of a collaborative nuts1 ecosystem. But I have to admit, I'm still a little fuzzy on the specifics. Can you give me a concrete example of what system software might look like in nuts1? How would someone actually use it?
Of course. Let's say, for instance, that a lot of nuts1 programs need to be able to interact with files on the computer. Things like opening, reading, and writing files are common tasks that many programs need to perform.
Right, I can see how that would be useful across a wide range of applications.
Exactly. Now, instead of having every programmer figure out how to do this from scratch, someone could create a set of procedures specifically designed for file handling.
So these procedures would essentially encapsulate all the complex logic of interacting with files, making it much easier for other programmers to incorporate those functionalities into their programs.
Precisely. These procedures would become a piece of system software. Let's call it, for the sake of example, Nuts File Handler. Other programmers could then use Nuts File Handler in their own programs without having to understand all the intricate details of how it works.
So they would simply call the procedures provided by Nuts File Handler, passing in the necessary parameters, like the name of the file they want to open or the data they want to write.
You're getting it. Nuts File Handler would handle all the low-level interactions with the file system, allowing programmers to focus on the higher-level logic of their applications.
That's incredible. It's like Nuts File Handler is acting as a bridge between our programs and the complex world of the computer's file system, abstracting away all the messy details and making it so much easier to work with files.
Precisely. And that's just one example. Imagine all the other kinds of system software that could be created. Tools for handling graphics, networking, sound, user interface elements, and so much more. The possibilities are truly limitless.
Wow. It's like we're not just learning a programming language anymore. We're discovering a whole new way of thinking about software development, where collaboration and code reuse are at the forefront. It's truly inspiring.
It is, and I think this brings us to an important point about the potential of Nuts One as a money programming language.
Okay, I was hoping we'd circle back to that. It's been on my mind this whole time. How does this whole system software concept tie into the idea of Nuts One being a platform for financial gain?
Well, imagine that someone creates a particularly useful or innovative piece of system software, something that a lot of other programmers would find valuable and want to use in their own projects.
Right, like our Nuts File Handler example. If it worked really well and made file handling a breeze, I can see a lot of programmers wanting to use it.
Exactly. Now imagine that the creator of Nuts File Handler decides to sell access to their system software. They could offer it as a paid library or module that other programmers can incorporate into their own programs.
Ah, I see. So instead of just building applications for end users, Nuts One programmers could also create and sell tools and components for other developers. It's like a whole new market emerging within the Nuts One ecosystem.
Precisely. And this is just one way in which Nuts One could become a money programming language.
Yeah.
The ability to create and sell system software, along with the potential for building and selling applications for various purposes, opens up a world of financial opportunities for those skilled in Nuts One programming.
That's incredible. It's like Nuts One is not just a language, but a platform for entrepreneurship and innovation. It empowers programmers to not only create software, but also to build businesses around their creations.
You've got it. And I think this is a perfect segue into the next part of our deep dive,
Whoa.
where we'll explore the real-world applications of Nuts One, the communities that are forming around it, and the potential career paths it offers.
I'm on the edge of my seat. We've gone from basic commands to building calculators to exploring the world of system software, and now we're venturing into the realm of real-world applications and career opportunities. It's mind-boggling how much ground we've covered.
Well, hold on tight because the journey is far from over.
Okay.
Nuts One still has plenty of surprises in store for us.
Welcome back to the Deep Dive. We're about to wrap up our exploration of Nuts One, and I have to say, this journey has been a real eye-opener.
It has been fascinating. We've uncovered so much about this seemingly simple language and its potential it continues to amaze me.
You know, in the last part, we were talking about Nuts One's potential as a money programming language. And the idea of building and selling system software, that really got me thinking. But I'm also kind of curious about what kinds of actual applications people are creating with Nuts One. Like, what can you tell me about that?
Well, the source material provides a glimpse into, well, both the types of software you can create with Nuts One and the software you can buy.
Ooh, a two-sided market.
Yeah.
Sounds promising. So what kind of things are people building?
On the creation side, the list is quite diverse. It includes things like a command line executor, various types of calculators, a down count timer, even a CUI operating system. There's also mention of a stars giver, though the source doesn't really elaborate on what that is.
Stars giver. That sounds intriguing. It's like Nuts One is sparking people's imaginations, encouraging them to think outside the box.
Absolutely. And it really highlights the versatility of the language. It's not limited to just specific types of applications. It's a tool that can be used to build, well, anything you can conceive of.
I love that. Okay, so what about the software that's already available for purchase? Any interesting examples there?
There are quite a few. Some notable ones include Nuts Listener 1, Nuts Opener 2, and Nuts Writer 2. They sound like they could be tools for working with Nuts 1 itself, perhaps for developing, running, or even writing Nuts files. There's also Blue Note 1, Nuts Hello Builder 1, and Nuts Builder 1, which could be, well, they could be development environments or tools for specific types of
So
applications.
there's already a whole ecosystem of tools and software built around Nuts One, and it sounds like it's still in its early stages.
Exactly, and that's what makes it so exciting. As more people adopt Nuts One and start building applications, this ecosystem will, well, it'll only continue to grow.
It's like we're witnessing the birth of a new programming paradigm. And it's not just about the technology itself, but also about the community that's forming around it. The source material mentions nuts programming companies and communities. What could you tell me about those?
Well, on the community side, there's the Nuts Programming Team and the Royal Society of Nuts Programming. These groups are, they're likely driving the development and adoption of the language,
Yeah.
providing support and resources for new programmers and fostering a sense of shared purpose.
It's amazing how quickly a community can spring up around a new technology. It's like people are drawn to the simplicity and potential of Nuts One, and they want to be a part of something new and exciting.
I think you're right. There's a certain appeal to learning a language that's accessible yet powerful, and the collaborative nature of Nuts One, with its emphasis on system software and code reuse, that encourages people to work together and share their knowledge.
And what about the companies?
Yeah.
Any notable players in the Nuts One world?
The source mentions several companies, including Global Junction, Nuts Technologies, Afrasoft, Royal Code Portal, GJ Shop, and GJ Host. Some of these names suggest they're directly involved in Nuts One development, while others might be businesses utilizing Nuts One to build their own products and services.
So it's not just hobbyists and enthusiasts. There are actual companies investing in Nuts One and building businesses around it. That speaks volumes about its potential.
It does, and as this ecosystem continues to expand, it's going to create new opportunities, not just for software developers, but also for anyone interested in learning how to code.
Speaking of opportunities, the source also kind of hints at some potential career paths that could emerge from the Nuts One world. What did you gather from that?
Well, the list includes roles like software development, software testing, software debugging, software documentation, and software design, which are all fairly standard roles within the software industry. But there are also some more Nuts One specific roles mentioned, like Nuts subroutine development and project representative, which suggest a more specialized focus on working within the Nuts One ecosystem.
And then there are roles related to teaching and distribution, which makes sense given the growing community and the need to share knowledge and make Nuts One software accessible. There's even mention of dealing Nuts One software, which further reinforces the idea of a marketplace for buying and selling applications and components.
Exactly. It all points to a growing demand for individuals with Nuts One skills and expertise. And as the language gains traction, those opportunities are, well, they're only going to increase.
So this isn't just some theoretical exercise in programming. Nuts One has the potential to create real jobs and economic activity.
Absolutely. And it's not just about the money either. Nuts One's accessibility and ease of use could democratize programming, making it possible for people from all backgrounds to learn how to code and build their own applications.
That's a powerful thought. Nuts One could empower individuals and communities, giving them the tools to create solutions to their own problems and shape their own digital destinies.
Precisely. And that's what makes Nuts One such a fascinating and potentially transformative technology. It's not just a programming language. It's a platform for innovation, creativity, and empowerment.
Well, I think we've done a pretty thorough job of unpacking the Nuts One phenomenon in this deep dive. We've explored its unique structure, its surprising versatility, and its potential to reshape the world of programming.
We have. And I think it's safe to say that Nuts One is a language worth watching. It's going to be fascinating to see how it evolves and what incredible applications people create with it.
I couldn't agree more. And who knows, maybe one of our listeners will be the next Nuts One superstar, building the killer app that takes the world by storm.
That would be amazing. And if any of our listeners are inspired to learn more about Nuts One, we encourage you to seek out those online communities, experiment with the language, and just, well, let your creativity run wild.
That's a great call to action. And on that note, we'll wrap up this deep dive into Nuts One. We hope you've enjoyed the journey as much as we have. As always, we invite you to share your thoughts and insights on our social media channels. Until next time, happy coding.